Today we are going to see about a case study, design thinking based video on vertical incidence measurement in ionosphere layer. Okay. In long distance communication, especially for high frequency systems, signals rely on ionosphere layer because the signals touches the ionosphere layer and reflects back into the earth. Okay. But our ionosphere layer changes its condition due to solar systems activity and based on time and its atmospheric condition, it changes its nature. So our signal cannot easily travel or propagate through the transmitter and receiver. Our signal prediction is a tough task. Okay, so we are going to find a solution for this based on design thinking structure. Is there any solution for that?
Okay, sir. First, I will start with the concept of design thinking. So, introducing the concept of design thinking, that is a problem-solving approach where we can solve the problem in 5 steps. First is empathy. Empathy is the customer's perspective where they find errors. We can see more number of errors in the antenna we in that error, the most common error which affects the whole environment is taken as in defined part. In defined part, the single problem statement is taken, and the ideate part, we will create some ideas in it with a combination of hardware and software too. And in a prototype, the ideas are converted into a model, a physical model, where it works and given to the customers to their testing part and get their feedback. And this design thinking video is getting recycled. So in empathy part, we know about the duct wave propagation, that is relaying the Earth's surface with the help of ionosphere. So, as we know, the nature's condition is not same at every situation. So, the solar activities and changes in time are playing as a factor in this. And the empathize part is we can't get a reliable way of communication.
We can't be able to predict the
signal easily. So, this is taken as the empathy part.
So next, coming to our define, it was the core problem of the defined part is the ionosphere of the wave propagation. So our first of the core problem is the ionosphere. First we cannot describe the problems of the ionosphere by varying of antennas. So at the first of ionosphere, it was difficult to measure or monitor the antenna propagations, and it leads to major communication problems in emergency networking and most of our communications. So next of our defined, it was a major problem of ionosphere to communicate between the two antennas wave propagation.
And coming to the ideate part, to encounter this problem, the technicians or scientists propose the vertical incidence measurement, but it is simple, but it is very useful to the communication part by transmitting the radio waves towards the ionosphere and see how it is observed and reflect back to the Earth's surface, where such as the importance of critical layer such as length layer of the height and critical frequency. This is also known as the hidden zone.
So in a vertical incidence measurement, we send that signal to the ionosphere layer, it touches and reflects back to the earth. So we measure that time duration. Based on that, we are predicting the signals of following signals.
So coming to the prototype stage, transmitter antennas in signals to the atmospheric plate upward, and receiver side captures the data from the atmospheric layer, and it usually called as a swiping up the large amount of communication data to the atmospheric layer. That output is called ionogram. The ionogram is the ionosphere. That is called the ionogram. And the ionosphere is used to protect harmful layer from the atmospheric layer, and it distance between 40 km to over 900 km, and we also protect the solar energy from the radiation.
Yeah, next testing part. We can test how the signal will be propagated into some other ways. We can overcome this problem into an HF signal. What is the HF signal? The HF signal is mainly used in FM radios and marine engineering, marine communications, and some other. The HF signal ranges as 3 MHz to 30 MHz. The signal is we can transmit even long distance. We can transmit even long distance, and we can activate even some long frequency range. And it will be more useful than we compare to isosphere, it will be very specifically identified by an HF signal, and it will be activating other areas.
In conclusion, the vertical incident measurement is useful for measuring that and predicting our transmitting signal at the receiver side. Okay, thank you.
Thank you.